So what we're given for this question is the second derivative, and then an initial condition for the original function, and then an initial condition for the derivative. Our goal is to find y equals. So it's a differential equation. You're just going to have to do it twice. So you're going to solve the differential equation once in order to get back to y prime, and then you're going to have to do it again to get from y prime back to y. All right, so here we go. Do the antiderivative. Now, antiderivative of e would be itself, so it's going to be e to the negative 2t. There's a u substitution there, but you're not going to want to write out u equals and then du equals for every single one of these. If there's a negative 2 there, you need a negative 1/2 out front. Just do the adjustment. Whatever's there, you just need to put the reciprocal out front. You can always double check. The derivative of this is going to give you this. There would be a chain rule. All right, plus, and then same thing here, it's going to be itself, e to the 4t. You're just going to need to divide by 4. So 10 divided by 4 would be 5/2. Or you can write 10/4, either way, fine, plus a constant. Now to find what that constant is, we're going to use this initial condition for the first derivative. So I just did an antiderivative. Now we're going to plug in 0 for t and 0 for y prime. It's going to give us 0 equals e to the 0 is 1 times negative 1/2 will be negative 1/2. Same thing happens here. So that's plus 5/2 plus c. So negative 1/2 plus 5/2 would be 4/2, which is 2. And so you get that c is negative 2. So I'm going to recopy that line and just put in the -2 for c. So that's solving a differential equation. And that's what I've shown you. We went from the second derivative backwards to the first derivative. This problem is just asking you to do that all over again. So you're just going to do the process twice to get back to the original function. So that was, doing the problem once. Now we're going to do another antiderivative to get from y prime back to y. So we went from second derivative to first derivative. Now we're going to go from first derivative to the original function. All right, so again, e is going to be itself. I'm just going to have to multiply on a negative 1/2. Negative 1/2 times negative 1/2 will be positive 1/4. And then same thing here. This is itself. You just have to multiply on a 1/4. So 5/2 times 1/4 would be 5/8. This would be -2t for the antiderivative, and then plus a constant. So again, you're just doing an antiderivative. The derivative of this would give you this. We just did it backwards. And then we're going to plug in this initial condition. We're going to plug in 0 for t and 1 for y. All right, so again, e to the 0 power is 1 times 1/4 would be 1/4. For the same reason, this one would be 5/8. We're plugging in 0 for t, so that would be gone, and then plus c. So 1/4, that would be 2/8 plus 5/8 would be 7/8. And so c is 1/8. So I'm going to recopy this line exactly like it looks. Except instead of plus c, I'm going to put plus 1/8. And so that would be your final answer. So it's a differential equation that you just had to do twice. I like that question because you really have to understand what they're asking you for. You have the second derivative. You have to solve the differential equation to get the first derivative, and then solve it again to get the original function. So you have to do it twice, kind of like a dream within a dream.